So as we have heat and pressure being applied to these metamorphic rocks, it's going to start changing the texture of the rocks. So remember, low-grade metamorphism is just a little bit of heat and pressure. All it's really going to do is compact the rock into a smaller size and make it more dense. High-grade metamorphism, on the other hand, is actually going to cause recrystallization. It's going to cause the minerals to grow in size as we squeeze them together. And as we go from low to high-grade metamorphism, we're going to see something called foliation develop. And this is where the minerals are going to start to arrange themselves into lines as they're responding to all of this pressure squeezing them together. So if you look at the upper part of this image, think about that round sphere being a ball of Play-Doh. And each of those little black marks is a quarter. You're going to stick those quarters into your Play-Doh at just random angles. But then using your hands, you're going to squeeze that Play-Doh ball with all those quarters in it in from the left and the right, like we see in the image. And you'll see that overall those quarters are going to start to line up vertically. This is happening because you're putting a lot of differential stress on the Play-Doh. You're changing the shape of it, which is causing the quarters to line up in one direction. This is called foliation, and it's what we see in high-grade metamorphic rocks. If we look at the image at the bottom, on the left-hand side, we're looking at a rock where the minerals are just randomly arranged. This is low-grade metamorphism. But once we apply enough heat and pressure to it, it's going to cause the minerals to align in layers, just like our quarters did in the Play-Doh. And this is going to lead to foliation, this kind of alternating stripes of light and dark minerals. We'll see that foliation happens generally from regional metamorphism, when we have an intense amount of pressure where mountain building is occurring. So all of this is due to compressional stress, squeezing objects together. With enough heat and pressure, this is going to cause foliation to develop, which again is just forcing the minerals to align themselves in kind of parallel lines throughout the rock. And if we get to a high enough grade of metamorphism, we're actually going to see that the minerals are going to separate out into light and dark colored bands. So the rock we see on the left is clearly foliated. It has alternating bands of light and dark minerals. But the rock on the right is non-foliated. It hasn't been exposed to regional metamorphism, so it hasn't been exposed to enough stress or pressure to force those minerals to align. So we're going to see that our metamorphic textures, in this case, they're the simplest out of the three types of rocks. Metamorphic only has two textures, foliated and non-foliated. And you tell them apart by whether the minerals have been forced into straight lines. Again, like the quarters inside of our Play-Doh were when we started squeezing it together. When we look at our foliated igneous rocks, we're going to be able to break them up and identify them based on the grade of metamorphism or how much they've changed from their parent rock. Looking at this diagram, as we go down, we're going to start with slate, which is a low-grade metamorphic rock. It's just compacted sediments where we can see the foliation or the lines of the sediments inside of it. But if we take this slate and we apply more heat and pressure, it's going to turn into a slightly higher grade metamorphic rock called phyllite. And phyllite's unique because it has a wavy appearance to it, and it has kind of a glossy sheen. But if we take this phyllite and apply even more heat and pressure, it's going to increase the metamorphic grade into a rock called schist. You heard that correctly, it's called schist. And schist is known because it looks kind of glittery. Here it's forming all of the minerals to compact into very straight lines, which are really good at reflecting light. But if I take that schist and I apply even more heat and pressure to it, it's going to turn into the highest metamorphic grade called gneiss. And gneiss is the one that has those clear alternating layers of light and dark colored minerals. But since gneiss is the highest metamorphic grade, if I apply any more heat and pressure to it, it's going to melt back into magma. It will no longer be a metamorphic rock. Our non-foliated metamorphic rocks are a lot more difficult to differentiate from one another, though. If you look at the upper image, this is a photo of marble. It is a non-foliated metamorphic rock that forms from limestone. Because it's from limestone, it's going to effervesce or react to acid and bubble up. But the image on the bottom is quartzite. It's made up of that mineral quartz, which is incredibly hard. So quartzite is going to be able to scratch glass. So with our foliated metamorphic rocks, you can look at them and be able to easily identify which one is which by looking at a photo. But for our non-foliated metamorphic rocks, we would have to do a quick test in the laboratory. If it reacts to acid, it'll be that metamorphic rock marble. If it doesn't react to acid but can scratch glass, it's a metamorphic rock called quartzite.